So how does it work and what's the point? Cryptocurrencies like Bitcoin allow people to transact with each other using the internet anywhere on Earth. Instead of having an account number like a checking account or a credit card, cryptocurrencies are much more secure because they have a public key and a private key. It's like having two account numbers, one for deposits and another for withdrawals. You'll often see them displayed as a string of characters or a scannable code. This level of security means that you could put your public key on a billboard if you wanted to, and your funds would still be secure. The only thing other people can do with your public key is send funds to you. It's your private key that gives you access to your funds. As long as you keep control of your private key, your funds are absolutely safe, and theft and fraud are virtually impossible. But, just like cash in your wallet, you need to keep it safe to prevent it from being stolen. Its security is entirely your responsibility. Cryptocurrencies can also give you privacy. Just like cash, you don't have to disclose any personal information when you spend them. By contrast, a credit card has your name, account number, and expiration date. These act like a public key, but the equivalent of your private key, your signature and security code, are displayed in plain sight. This is just plain stupid. I've toured 5 national money museums, and while I was at one of them, I saw a group of young students on a school outing. I can just imagine that someday in the future, a group of kids will be standing around the credit card display, pointing and laughing at the incredible stupidity of the system we once used. And this is the point. Cryptocurrencies are light years ahead of our current technology. Since Bitcoin was the first cryptocurrency, I'm going to use it as our example, and I'll expand on our earlier description of a distributed ledger. But first, where does Bitcoin get its value? Bitcoin is brand new to mankind in that it's both a currency and a payment network simultaneously. And this is where Bitcoin gets its value. The immense network of computers all around the world running the Bitcoin distributed ledger. Every second of every day, these computers are keeping the ledger updated and in full consensus via a system that incentivizes them to process and confirm transactions. The system that Bitcoin runs on is called blockchain. Think of it as a modern version of an old-fashioned bookkeeping ledger, but instead of a handwritten list of entries and calculations, a blockchain is a digital list of entries and calculations. A block is simply a bundle of transactions. Think of a block as a whole page of transactions in the old-fashioned ledger. A blockchain is just a chain of blocks. It's the same as a whole series of pages in the old-fashioned ledger. Easy, huh? Here's how it works. The Bitcoin blockchain actually exists in every one of the millions of computers on the network as exact copies of each other. However, for this example, so that we can zoom in and you can really see just how a blockchain works, I'm going to show it as one giant blockchain in the middle of a small network of computers. Let's follow a pizza transaction with Bitcoin. When the transaction occurs, it first appears on the network in a pool of unconfirmed transactions, along with thousands of others from all around the world. Millions of different computers from the network then gather some of these transactions and place them in their own blocks. The computers are all creating blocks constantly in the hope that theirs will be the next one added to the official chain. A new block is added to the chain every 10 minutes or so, when one of the computers wins the right to have its block recognized as the next in the chain and is rewarded with a prize of newly created bitcoins. The way a computer wins the prize is by trying to guess the answer to an extremely difficult math problem. In fact, the problem is so difficult that even with millions of computers making guesses billions or even trillions of times per second, it still takes roughly 10 minutes to find the answer. Once one of the computers guesses the correct answer and wins, all of the millions of computers on the network that did not win are instructed to throw away all the work they have done, update their ledgers with the block from the winning computer, and start again with a new math problem. In doing so, the computers use an immense amount of power and cost a literal fortune to run. So why do they do it? Because it can be very profitable. This is where the term mining for bitcoins comes from. Instead of striking gold by mining for precious metals in the wilderness, these computers are hoping to strike Bitcoin by mining precious numbers on the blockchain. But when these millions of computers are selecting transactions to go into their blocks, they aren't all selecting the same transactions, and not all the blocks are the same size. Some contain more transactions, some contain less. When blocks are thrown away, the transactions they contain go back into the pool of unconfirmed transactions. This means that the probability of a transaction being confirmed and staying in the order it was confirmed in is not absolute, but it becomes more of a certainty every 10 minutes as new blocks are added. In fact, for very large transactions, it's suggested that you wait for 6 or more blocks, about 60 minutes, to be absolutely certain that a payment is permanent. So why is it so slow? Why is your pizza cold before you own it? Interestingly, the system is slowed down on purpose, and here's why. With the insane difficulty of guessing the answer to the math problem, you would think that the odds of 2 or more computers winning at the same time are extremely improbable, but it actually happens quite often. This is called a soft fork, and when it occurs, all the computers in the network receive both of the winning blocks and are instructed to create a new block that will chain to the block they received first. But because of varying internet connection speeds, different computers receive different winning blocks at different times. The tie is broken roughly 10 minutes later when one of the computers solves the new math problem and its block is added to the ledger, and the longest chain wins. But what happens to all of the blocks on the other side of the fork? They're discarded, along with all the transactions they contained, which go back into the pool of unconfirmed transactions. This soft forking is the main reason the system must be slowed down on purpose via the math problem. If the system was instant, it would be forking everywhere, all the time, and there would be no consensus. No one would have any idea of which ledger was the correct one, and every computer would be busy building a different block to create yet another fork. The slowness and immense amount of computing power is required to keep the Bitcoin ledger in full consensus. Therefore, as more and more computing power is added to the network, the system automatically adjusts to increase the difficulty of solving the math problem, which then requires even more power. If Bitcoin is ever going to be widely used, it will be using a massive amount of the world's energy. There are other systems for reaching consensus, but we'll look at those later in the episode. For now, Bitcoin is working as intended and allows people to transact with each other using the internet anywhere on Earth. Bitcoin, it's the first full consensus distributed ledger that mankind has ever seen, but it's not the last.